So for our review, guys, first thing here, this table is going to be used for questions 1 through 6. How this works is, out of the materials here, if two materials get rubbed together, whoever's higher of the two has a stronger attraction for electrons, will take electrons from the other guy and become negatively charged, leaving the other guy with less electrons and possibly charged. For example, if we took silk and silk was rubbed with paper, since paper is higher above it, paper takes the electrons, making paper negative and silk overall positive. But if silk were rubbed with anything underneath it, silk is stronger, so it takes the electrons and it would become negatively charged. So that's kind of where we did 1 and 2. Now number 3, which one produces the larger static or stronger static charge? With cotton t-shirts and a dryer. So how that works is it's the greater the difference of separation on the chart. So cotton is here, then we have silk, wool, and nylon. Since nylon's farthest apart from the cotton, it's the weakest of them all. So the cotton is able to take more electrons from it, right, making it more negative, the nylon more positive, and since there's a greater difference in charge, now you're going to wind up with a stronger static charge. So that is why that is nylon there. 4 through 6. Predict the charges of the underlying object. Okay, so rubber rod that is rubbed with wool. Rubber is up top here. Wool is below it. So yeah, the rubber rod is going to become negative. Glass tubes rubbed with cotton. Well, glass is here, down at the bottom. Cotton's up top. So who's going to take the electrons? The cotton will, because it's stronger. So if cotton and glass are rubbed together, the cotton would become negatively charged. But what are they asking you for? They want you to predict the charge of the underlined piece. So the glass would become positive. PVC pipe with paper. PVC is all the way at the top. So PVC is literally going to take electrons from everybody underneath it because it's stronger than them. So PVC is going to be negative. So if you don't get this exact table tomorrow on your test, all right, but it's one similar, you also just pay attention to the direction the arrow is going, whether it's going up or down. All right, it's still going to be done the same way, but if this arrow was angled downward, all right, let's say we talked about nylon. Anyone below it, right, if the arrow, let's say, was going this way, that would mean, oh, the dudes, as you go down, they have a stronger attraction for electrons. So if we said nylon was rubbed with glass, glass would be stronger, so it would become negatively charged. Nylon would be positive. If nylon were rubbed with anyone underneath it. All right, so again, that is dependent upon the, oh, let's go back. Let's get off the pen. Let's go to mouse. That is all dependent upon the direction, all right, of our chart there. Number 7, electric forces between charges are strongest when the charges are what? What do we think?
Close together.
Good. Closest together. Okay, think about the Newton's, the Coulomb's law simulation. All right, with the two guys like dragging the charges, okay, and how when they got super close together, the magnitude, the vector, got jacked up, either positive or negative. Coulomb's law states that the force between any two charges depends on what? Well, it's directly on the magnitude of the charges. So that's basically saying as charge goes up, so does the force. Is that true? That is true. Does it also depend on, all right, is it also inversely proportional to the distance between them squared? Yeah, it is. So it is both of them. Number 9, two charges are separated by a certain distance. If the magnitude of each charge is doubled, the force is going to do what? Well, if you did this, right? If we set everybody to like the ones equation, we have K, but that's constant, so we don't care about that. Okay, you have Q1 times Q2 over D squared. So since K is a constant, we don't really pay attention to that. So we're just basically going to say you have the charges on top, 1 times 1, and on bottom you have the distance, which we're going to call it a 1, but distance is squared. So two charges are separated by whatever distance. If the magnitude of each charge is doubled, what would the force be? Well, that means each charge, instead of them being a 1, okay, we would turn them to 2's because they both doubled. So we'd have 2 times 2 over, and because the distance didn't change, all right, it's still a 1 squared. So 2 times 2 is 4, and 1 squared is 1. 4 over 1, it's 4 times the force, or in this case, it is quadruples. Okay, everybody got that? Understand that? Okay, so if you're looking then at kind of the ones piece, the ones equation. Number 10, when the distance between them doubles, what happens to the force? So the charges up top don't change. So 1 times 1 on top. Distance is on bottom. That changes. It becomes what? Double. So we'd have a 2 on bottom. So it would be 1 times 1 on top divided by 2 squared on bottom. So what does that come out to be? So you would have this 1 times 1 over 1 squared. So the charges don't change, so they would both stay 1. Thank you. Good. Okay, the bottom would become a 2. This reduces to, or simplifies out to 1/4 of the original force. So we're going to make sure you guys highlight C. All right, you guys should each be able to, you should 100% be able to do 11 on your own. Static charges are charges that do what? Well, we haven't really talked about flowing through wires. We haven't really said much about batteries. Involve a transfer of protons. Do protons move? Are protons exchanged back and forth between the atoms? No. What are? Electrons. So by process of elimination, okay, static electric charges are stationary charges. 13, you guys should 100% know. Neutral object. What is true for 14? All right, so neutral objects are never going to be repelled by anything or repel anything. Is it true that they are attracted, or positive charges are attracted to it, or they're attracted to positive? That is true. But it's also true that the same thing with negative. So it could be either attracted to a positive or negative. So we're looking for letter D here. An electroscope was the diagram that we used specifically was like the one that looked like a stick figure head with a straight line down, and then the two little flaps down at the bottom. When neutral, the flaps just hang straight. But when they have a charge, if they have the same charge, they kind of flare out underneath at the bottom. So these electroscopes detect static electricity, not just positive or negative. What happens when a positively charged rod is brought near a neutral plastic ball? So, you guys, on the test tomorrow, I would suggest having a piece of scrap paper out. And this one may just be easier to draw it out. So, a positively charged rod. is brought near a neutral plastic ball. So this is neutral, right? We have the same number of positives and negatives. Opposite charges do what? Attract, and like charges repel. So all the electrons in here are going to, do you think they would be attracted to all that positive charge? Yeah, they would. So the electrons would kind of, come on, there we go. They would move themselves, from spread out being all over evenly, they would kind of position themselves to make this side of the ball more negative. Now, because of that, what is the best option here? Protons are attracted? Absolutely not. The protons are repelled? No, the protons are not going to be the ones that move. So electrons, are they repelled to the far side? No, but they are going to be attracted to the near side. That would be the one that you'd want. What the hell? Hmm. What do you mean?
You said what the hell?
Oh, I was trying to edit something and it moves. Now, number 17, an electric charge that results from the presence of a charged object nearby. No direct contact is called what? What does that exactly mean? See how here there's no direct contact. This was neutral. All right. Because all the electrons move to the near side, that makes this side of the ball or object mostly negatively charged and this side mostly positive charge. So when that has happened, we are saying this is induction. So here you're looking for letter B, induction. Number 18, a charge resulting from contact. That is straight from our notes. What should that be? Yeah, conduction. Contact, conduction. Okay, this is a solid piece. In which direction would this positive test charge move? So there are two negatively charged rods here. Opposites do what? Attract, right? So if let's say the left rod was not there, what would it do? It would go straight down, right? That would make sense. Okay, but there's also got over here. So what do you think it's actually going to do? Which letter do you think makes the most sense then? Which? D. All right, because it would be moving down and towards the left. So it would go split the two. So you're looking for letter D here. Yeah, you can't highlight that one. You're actually just use the letter there. Now you have 5 diagrams of a metal sphere. There are positive and negative signs to indicate the net charge on the left and right sides of the sphere or the overall charge. So for each question, place the letter of the diagram that best represents the scenario on the space provided. So 20. A negatively charged rod is brought near but not touching the left side of a neutral sphere. Again, scrap paper may help. We just basically did this one up here, except we did it with a positively charged rod. So if a negatively charged rod is brought near but not touching the left side of a sphere, what is the one that's going to be? Which diagram best represents it? Positive rod is brought near but not touching the left side of a sphere. So we just did that one up here. Positive rod is brought to the left side of a sphere but doesn't touch it. What happened to the charge? The negatives were attracted to the positive charge, so they moved to the left side of the sphere, making that side more negatively charged and the right side more positively charged. So if a positively charged rod is brought near but not touching the left side of the sphere, which one makes the most sense there? B. Now, let's see. A negatively charged rod touches a neutral sphere. So if it's conduction, the neutral object will take on the same charge as the charged object. So if a negative touches neutral, then that neutral sphere is going to become overall negatively charged. Okay, so now we have a rubber rod becomes negatively charged after rubbing it with fur. Okay, the fur is then taken and touches a neutral sphere. So they want to know what the charge on the sphere is. So if the rubber rod becomes negatively charged, so the rod becomes negatively charged. And I don't know, here's the fur. If those two rub together and this guy took the electrons away, becomes negatively charged, what would the charge on the fur have to be? Thank you. So this is going to become overall positive, right? So then they're saying, okay, well now the fur is then touched, is going to go and make contact, right? It touches the neutral sphere. So that's conduction. And if that's the case, the neutral sphere or the neutral object will take on the same charge as this dude. So if the fur makes contact here, then both the fur and the sphere will be positive. So we're looking at letter C for the answer here. Okay, true or false? Two objects have negative charge. Will they attract each other? No, they won't. Negatively charged rod touches a neutral metal conductor, which then becomes charged. This is an example of induction. No, that would be conduction. 3, a neutral object has equal numbers of electrons and protons. Yeah, that's true. Whenever you ground a positively charged object, the electrons flow from the object into Earth. No, I'm gonna, sorry, so if this was the object and it was what? Positively charged? And we provide a path to the ground where we can either gain or lose electrons to try and make it neutral. If this thing has a positive charge, what would it want to become neutral? So if I wanted to make this neutral, what does it need?
Or negative.
Yeah, it needs electrons. So when this is saying electrons flow from the object to Earth, well, if that's the case, this thing's just going to become more positive, which we don't want. So when we ground it to get rid of that charge, the electrons can flow either way. So the electrons would actually move from the ground to the object. So the electrons would move from the ground to our object. So this one would be false. In a conductor, electrons cannot move freely from atom to atom. That is false. In a conductive material, the electrons do move easily and freely. 6, only protons can move. Nope, absolutely not. Protons are not moving. Okay, it's the electrons that are moving around. So 6, false. If sodium atom loses an electron, it becomes negatively charged. Well, all right, so let's just say, I think sodium is a 10 or 11. I think it's a 10 or 11. All right, real quick, do it. Sodium. What's the atomic number? Okay, so since it's 11, if something is neutral, it would have the same number of protons as electrons, right? So this says if it loses one electron, well, now how many electrons would I have? How many?
10.
You'd have 10, right? So now overall, what would the charge be on this thing? Negative?
No, 10.
So you have basically a positive 11 and a negative 10. So what would my overall charge be? Positive 1. So then is this correct? Nope, it is false. 8. Two objects, each having negative charge, will repel each other. Yup. Like charges repel. Like charges repel. So guys, we did this the other day. They're just in possibly a different order. So what you need to do for this is count up the number of positives and negatives you see. Okay? And figure out whether or not it's positive, negative, or neutral. If they're both neutral, what's going to happen? Nothing. If they're both, if they're opposites of each other, if one's negative and one's positive, it's going to attract. If it's a neutral with either a positive or a neutral with a negative, there will be an attraction force, and then it will be repelling if both of them are positive or both of them are negative. So we will do just one of these. Pick one. 1, 2, 3, 4, 5, or 6. First number. T.
4.
All right. I heard 5, 4. So
Do both.
no, I'm not doing both. That's ridiculous.
Yeah, do both.
No, you're babies. No. So 4. How many positives do we have here? We got 1, 2, 3, 4, 5, 6, 7, 8, and 2 negatives. So this is just overall. I'm going to say, okay, this dude is positive. What about this guy? I have 1, 2, 3, 4, 5 negatives, and 1, 2, 3, 4, 5 positives. So same number and same number. What would that be? Neutral. So I'm just going to write a lowercase n here. And a positive and neutral object, if they are brought near each other, what is it going to be?
Attraction.
Mm-hmm. All right. Are you still there? All right. So you guys are going to do the same process for these ones here. Numbers 1 and 2 for the problem solving. You are given Coulomb's law equation. Charge 1, charge 2 over the distance squared. They need to be in coulombs, which they are, and the distance needs to be in meters, which they are. So the equation for this, F is going to equal, you got to do 9. I'm just going to copy and paste because I'm lazy here. Copy this dude here. So I got 9 times 10 to the 9th. Oh crap, I need to get out of exponent. So that would be control period. Go back down. Times this. Times. Could I just write it out? I could, but I'm being lazy. And I'm going to get rid of the C because that's just easier. And what am I going to do? I divide by the distance squared. And the distance here is 5, so it's 5 squared. Then what am I going to do? Well, then I'm going to open up my calculator tab. Create new tab. And type in calculator. And then I'm going to look at my numbers. 9 times 10 to the 9th, 5, negative 8, 1, negative 7, 5 squared. So I'm going to do 9. All right, times 10 to the, so I have to click on this x to the y. And once I see that little box, then I can type my exponent. To the 9th. All right, good. Times, what was our first number?
5 times 10 to the negative 8.
All right, so 5 times 10, exponent, negative 8, close parenthesis, next, and then it's 1 times 10 to the negative 7th, close parentheses. That's on top. And then I'm going to divide that all out by 5 squared. Okay, and I'm going to get an answer of 0.000018. So, that'd be awesome if I can copy it. Oh, dang, that's, we're going to reduce the size of that because that's just obnoxious. All right, what is the unit for force? Newtons, ba-bam. Okay, you're going to do this, you'll use the same idea, same method for number 2. Okay, the next one, field lines. So for us guys, electric field lines, the thing that we were dealing with yesterday. Here are the few rules. Ready? Positives, the field lines come out of the positives. They go into the negatives. The more lines there are, right, the more densely packed they are around it, the greater the charge is going to be, the greater the electric field is going to be. So right here, A or B, they want to know, is A going to be positive or negative? Well, are the field lines coming out of it? Yerp. So then we're going to say positive. What about B? Are they going in or out? In, so that's negative. C, what's going on with C? Positive or negative? Positive. Are they moving in towards D? Yup, so that would be not negative. E, what are they doing? Are they going into E? They are. They're coming out of F. So E would be what? Negative, and F would be positive. And then we have G, H, and I. So, oh boy, what do we got here? G is positive, right? They're coming out of G.
They're all positive.
Coming out of H and coming out of I. Okay, so with this one, here's another rule that I forgot to mention. The field lines will never cross. The field lines never cross. So you see how G is positive and so is H. They're kind of moving, radiating out towards, but as they get close, they're like yeet. They kind of curl up and away from each other. So they'll never actually cross, but yes, all three of them are absolutely positive. So now what we got to do is, I already gave the answers apparently here. Darn it. But this wanted to know the strength. So how this works is, which one has more lines essentially? Who has greater lines, A or B? So A is greater than B. I already typed this in for you, so we're just going to go over it. Who has more field lines? D. So D is greater than C. God bless you. E, F, and G. Which one has the least amount? G. So G would be the weakest. Then which one? E, and then F. So G, E, F. Good. Holy crow, look at this thing. Yeah, which one has the most? I, definitely. So I is the strongest. Then which one? Then H, and then J. Okay, and that is already done, bam, for you.
Yeah, that's real easy.
That's easy.
That's very.
Can you go back to this person?
I will, just give me a minute.
I know.
All right.
That might be hard.
Now, the next one here, so number 1, what I'm asking for is, there are 2 negative charges. Which picture correctly represents how they would react to each other? A, B, C, or D? Or E?
D.
D?
E.
E. E. E would be over here?
A. C. G. already said C. You said everything. Yeah,
All right. Well, just I'm just shouting out letters like it is C. You knew it after saying half the alphabet. Got it. F or A could potentially be dependent, but their positions would need to be a little bit different. A would need to be a little bit closer to the spot here, but they are going to repel each other, and so C is going to be the one that we're going to go with here. So remember, like charges repel, opposites attract, neutrals with either charge can attract. All right, 2 is positive charge, 3 is an opposite charge. You guys should be able to figure that out. Number 4, plastic rod is rubbed with animal fur. The rod acquires negative charge during this. So then what is true about the charge of the fur? It does acquire a positive or negative charge. If they're both rubbed together, first neutral, now the rod becomes negative. That means the fur has to become what? So that means C and D are automatically eliminated. So does it gets positive charge greater than the rod? Does it get positive charge less than the rod, or positive charge that's the same magnitude?
E.
It would be E. Think about it, right? So let's say they get rubbed together and it takes 10 electrons away from the fur. Well, now the rod has got a charge of negative 10 and the fur would have positive 10. Right? It didn't lose less or gain more or whatever. So, bang, boom. Number 5, positively charged rod is brought close to the end of a neutral metallic plate. What type of charge is induced on the side that's closest to the plate? So the side that's closest to the plate should be what kind of charge?
Positive.
So if the rod is positive, what? Right? So if this thing was like equal number of positive negatives here, what is attracted to the positives? Negatives. So the negatives that were evenly spread out, they're all going to kind of pile up over here, right? Because they're thirsty. They're over here, all right, trying to get to this positive charge. They're like, hey, yo, what's up? Now, this side of the plate side that's closest to the rod is going to be neutral. I'm sorry, negative. Sheesh.
Is this test on quizzes?
Yes. Number 6, positively charged rod is brought close to the end of a neutral metallic plate. What type of charge is on the farthest side? Well, it's going to be positive. All right, if all the negative goes to this side, all right, that's going to leave positive over here. Oh boy. Number 7. Aha. Okay, so number 7 is a little bit of a trickster, but we can do this. Positively charged sphere A is brought close to B, but does not touch. Then B is then touched with a grounding wire. So what is the charge on B after the wire is removed? So let's pretend like the wire is not there first. So a positive charge is here. What side should be negatively charged? The left side would be, right? The electrons would be attracted to this positive charge, which would leave this side over here positively charged. Does that make sense? Okay. So now, then they add the grounding wire. So the grounding wire is attached over to which side? The positive end or the negative end? The positive. So the grounding wire is like thinking, wait a minute. My job is to try and make sure this spot is neutral, or the thing is neutral. And if this side is a bunch of positive, how could I neutralize it? By adding what? I would have to add electrons. Does that make sense? So by adding these extra electrons here, high, 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 and then they take the wire away, well, now you have more negatives than you originally did. So we are going to have the fact that B is going to be a negatively charged. This would be the reversed. If this was negatively charged, it would be the reversed scenario of this. So it would be, if this was negative, this side is positively charged, this side over here is negatively charged. Then they bring the grounding wire in, and because this side is negatively charged, to try and neutralize it, they're like, yeah, you have way too much negative charge over here. So some of these electrons would leave and go into the ground. And then, yeah, because some of them left, and then once you remove the wire, well, now there's less electrons than you originally had. So it would be positively charged. So inducing a charge like this, it's always going to be the opposite. Where it's conduction, if they make contact, they're going to take the same charge as the charged object that was touching them. So if a negative rod touched the neutral sphere is now negative. Positive rod touches the neutral sphere is now positive. All right. So you guys still have a couple questions left to do and work on, so make sure you please do. Okay. Questions can be pulled from the quiz that we had on Monday, from the interactive or the simulations that we did, the investigations. It can be taken from Coulomb's law, the Coulomb's law proportionality worksheet. It can be taken from a couple different pieces, all right, as well as information that is on here. So just keep that in mind. All right, again, test will be open tab. It will be on quizzes. We'll have our 2 attempt. All right.